Hey guys, thanks for tuning into CMTEQ channel once again in this STM32 embedded system programming. In this tutorial, I'm going to reduce this code we wrote for the binary counter because it is important to remember as an embedded system engineer, you might not always have the luxury to have a huge flash memory where you can write an amount of program that as possible, like this particular one here. This is up to 64 kilobyte of flash memory. Now that is expensive. So if you are building an embedded system with a firmware that going into a small device, and the microcontroller you're going to use might actually just have about 2 kilobyte or 3 kilobyte of flash memory. Okay. And when the flash memory is that small, that means you have to be very creative in writing your code so that you can save space. So it is in that background that I'm just going to attempt to reduce this code slightly. And also, instead of using an if-else ladder, I'm going to replace it with a simple switch cases. So stay tuned until the end and see how we're going to reduce this program. Okay, so first off, where we are configuring our GPIO pin configuration, we've got two GPIO functions here for A and B. Now I'm going to combine it just to make it one function that's going to configure both GPIO B and GPIO A. And I'm going to call this function GPIO config. Now the first line here, you can see we are accessing the same register. That is the RCC register that enabled the clock. So we saw that pin 17 or bit 17 rather is the one that is enabling the clock for GPIO port A. And 18 is for port B. So which basically means that if we copy this line of code, right, and we all here, we all there like that, that basically means we're going to be enabling this bit and this bit. That means GPIO A and B both will be enabled. So that means we can dish out this line of code, right? Now, here, there is nothing we can do. We have to still configure our pins. And the output type register to be enabled bits that we may or may not do away with that. Our program might still work, but for now let's leave it off. And here in this line of code, GPIO B model, we were basically setting the port as input and then pulling down the selected pins where the buttons are connected. So which means we cannot do away with that. So I'm going to copy them and then just paste it here. So which means this function can go away. Since this function is gone, now I can go into my header file where I've got function prototype and I need to change things here. So this function is no longer there, and this one have been renamed as just GPIO config. So now I only have one function that is dealing with the configuration. Now in the main function here, we can already dish out also this line of code because we only now have a single function that is doing the configuration for us. We're still going to be using these variables. Now we can go inside the while loop, and because we want to change the if statement into a switch state, right? Because you can see that in this if statement, we are executing lines of code. These are lines of code being executed, and they are actually taking memory spaces, which is a flash memory that is very expensive in a microcontroller. So what we're going to do is we're gonna replace it with a switch case. What we are particularly interested is this GPIO IDR register. As you can see, the IDR register is the one that we are reading the buttons. So when we press, we are basically reading the buttons with that register. So which means at any given time, there is a state in that IDR register. So we can check the state of that IDR register and then return a particular value. Once we return a value, we can be able to determine whether which button is pressed or whether it's both button or what is the condition of the buttons. And that can translate into different switch cases, right? And then inside where we are executing here, right now we are making use of the GPIO bit set register. So that is for the reset and for the set, right? Now we can also replace this just with using GPIO ODR, which is the output data register. But let's first focus with the buttons, okay, so that we can get rid of these codes that is doing the shifting into the GPIO IDR register. Now to do that, I'm going to declare another variable, and I'm gonna basically just say it's unsigned. It's unsigned long. Why is it unsigned long? Because this is going to be the whole GPIO B register value that we're going to store in this variable. So then we come here inside our while loop, and then we're going to call that variable. We're going to say GPIO B val, that is equal to GPIO B, and then we access the IDR register like that. Now we know that GPIO B val will be holding the GPIO B IDR register value. Alright, so what are we doing with this information? Well, this information is important to us because now we know that we are dealing with two buttons that are connected on pin 8 and 9. And pin 8 and 9 are here, the two locations. And we also know that our buttons are internally pulled down. So which means the GPIO IDR is reading 0 on the input because they are pulled down. So which means GPIO B val that we just declared is just reading 0, 0, 0, assuming that every other bit are 0, 0 upon reset. Now, what will happen is if we press both buttons, now we are pulling them up, right? So which means we're writing a 1 here on GPIO on pin 9 and also a 1 on pin 8. What is this value? This is 2 bits. So 1, 1 is a representation of 3 in decimal, right? So that's the highest number we can have when we press the 2 buttons. So that will be 3. If we only press 9 and release 8, we're still going to have a 1 only. The same will apply if we release 9 and only press 8. We're still going to have 1. So which means the highest number is going to be a 3, which is a 1, 1. The trick here is these conditions are only going to occur when we press the buttons. So which means as is the register is like this. So in order for us to record this state, we need to do an AND operation. An AND operation with what? An AND operation with the highest value, which is 3. How are we going to do that? So the trick here is, as we're standing here, we're going to write a 3 here. 1, 1. This is the value that we're going to read the highest. Now what we're going to do is we're going to shift this 3 by 8 to the location where these binary bits are going to be changing. That is on pin 8 and pin 9. Now in order for us to get there, we have to shift 8 times to the left. So we're going to shift 8 times these bits. So let's go 1, 2, 3, 4, 5, 6, 7, 8. We write a 1. So that one is gone. And now we take this one again. 1, 2, 3, 4, 5, 6, 7, 8. And we write a 1. So now this one is also done. So what we've done here is we've performed a left shift, the binary number 3. Now we are standing here. And what we're going to do when we are here, now we're going to do an AND operation with the current value on the register as is without someone pressing anything. And when we do an AND operator, between this and this, we know what's the result. So 0 and 1 is going to be a 0. Because in order for us to get a 1 here, right, we need to get a 1 here. These bits must be a 1 for us to get a 1 here. Now, if this bit is also 0, then we're still going to get a 0. Right? Then we take these 2 bits here, 2 zeros. We shift them back to the right. Right? We shift them back to the right. So, also by 8 bits. So, we're going to go. Let's start by this one. So, that will be 1, 2, 3, 4, 5, 6, 7, 8. So, we write that 0 there. And then we take this one. We shift it also to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Then we write the bits there. So, this value is the value we're going to be passing into our switch cases. Now assume that no buttons are being pressed. That means the entire register here is 0, 0. Then we shift 3 onto the left by 8. Then we've got a 1, 1 here. Then we perform an AND operation with the register and the 3 bit that we just move left by 8. And this is a result. And we take the result, we shift it back to the right by 8 also. And this is going to be the result of our switch case. So that means right now with no button press, we can see that the result is actually 0 because 0, 0 is basically 0. Now let's go into our code. So now what I was saying basically means I have to declare another variable. Okay. Now this variable is also going to be unsigned long, and I'm just going to call him button state. Right. So that's a button state. Now I take the button state variable, then I come here say button state is equal to GPIO B value. I take the GPIO val and do an AND operation with a 3 unsigned long shift left 8 times, just like I explained there. Now we know what will be the result of this operation if no buttons are pressed. So the result of this operation, as I've shown there, is that if no buttons are pressed, this will be equal to 0. That means the button state here will have a result of 0. Now I'm going to take the result of this operation, which is now stored into the button state, and now I'm going to take that result and shift it to the right 8 times as well. And that's going to give me the result for my switch cases. And that result must be also stored into a variable, which I'm going to just call an integer variable and call it switch and initialize it to be equal to 0. Then when I call it here, say switch is equal to, I'm just going to now take button state and I'm going to shift it right 8 times. And that result is now going to be passed into our switch case. So I open the switch statement here, right? And the switch statement is going to be reading the variable SW. As per the value of SW, then we're going to be jumping from case to case. So we say case 0. Now we're going to write the code here for case 0. After writing the code for case 0, then we're going to break, right? Now let's go back into our Excel spreadsheet here and look at when will we get case 1 and case 2 and also case 3. Now assuming that button 8 is pressed, which is counting up. Now if button 8 is pressed, what's going to happen is I'm going to have what? A 1 here. So if I've got a 1 here, now you can quickly see that 1 and 1 is now going to give me a 1. And this is still going to yield a 0. Then I take this, I shift it again 8 times. And as a result, I'm going to get a 1 here and a 0 there. And what is this? This is a 1 in decimal. So basically, case 0, we know what case 0 is. And we can also say we know what case 1 is. Because case 1 is going to be the count up. Now let's go back and check for case 2. Now case 2 will mean this one is 1 and this one is 0. So that is when we press button 9. So when we press button 9, 1 and 1 is going to be a 1. 1 and 0 and 1 is going to be a 0. And we shift these 8 times and we're going to get a 1 and a 0. And this in decimal, this is number 2. So which means case 2 is when we are actually counting down. And then we break. Like that. Now we go check when all the buttons are pressed. Now when all the buttons are pressed, that means we're gonna have also a 1 and a 1 there. So if we got a 1 and a 1 and we end here, obviously you can see 1 1 is 1, 1 1 is also 1, doing an AND operation. And we then shift this again 8 times to the right, and we're going to get a 1 1, which gives us 3 in decimal. So this 3 is going to be our case 3, and then we break. Now we know that case 1 is when we're pressing this button, and case 2 is when we're pressing this, and case 3 is when we're pressing both of them. So what is going to be case 0? Well, case 0 is when no buttons are being pressed. We can actually just run this code that we are running here. That's a code when I press here and then it flashed twice. So we can just put this code into the case 0 there. Then problem solved. And to close off the switch statement, we should have a default case. So in the default case, we're going to put nothing in there, right? So there will be nothing in there. You can press any code you want to in here. Now we can go ahead, just copy all the codes that we've got under these if-else ladders into our specific case. So we say that we're going to place this code into case 0. So I'll just come here and paste the code into case 0. So at the end of this tutorial, where I'm going to combine these 3 lines of code into a single line of code. Right now you can see we've got how many 3 variables that we are using into these lines of code. This is still not good for memory management. So we have to learn how we can combine this into a single line of code. So stay tuned until the end and you see how we're going to do that. In the meantime, let me copy this code under my count up. So this is going to be case 1. So I'm going to come here and paste it into case 1. Now I need a code for case 2, that is a countdown. Copy that and paste it into case 2. Now I need case 3 code. So case 3 is the sequence code. So I'll also cut it rather, the code for the sequence and paste it under case 3. So now I don't need all these if-else statements. So I will just come and remove them like that. Okay. Now let's build this and see if everything is fine. Alright, the code executed with no error with the switch statement in there. And I'm going to just auto align it. So I'll just hit Ctrl Shift and F so that we can auto align the code inside the cases. Okay, now that that is done, we can basically just write it in and see if we haven't messed up the code yet. So let's load it in. Okay, verify, download complete. Okay, well, let's just test the code. So I'll start with the sequence. Well, the sequence is still working, right? Okay, it's flashing, right? That's a startup. So it's flashing. So this is my countdown, and you can see I'm counting down. Okay, and this is my count up. And you can see I'm still counting up and it's still flashing. So which means what we've computed here is indeed correct. Now before we combine this line of code, let's replace this GPIO bit set reset register into a single register that is a GPIO ODR, output data register. Now as you can see, we are doing a bit set and then we're doing a bit reset. Now the bit set and bit reset are actually writing the value into the ODR register. So if we go straight into the ODR register, we can bypass this register as we saw in the previous code. Now if you come inside the ODR register here, you can see that we also going to be making use of the 16 bits register. The other register, they are not in use. And the reset value is 00. That basically means it's 00. It's off. So which means no LEDs will come on. The LED will only turn on when there is a 1. So the thing is 00 upon reset. So which means we don't have to worry about resetting it or setting a low onto the bits. All we have to do is to set a 1, because if we set a 1, then we know we're turning on the LEDs. So having said that, assuming that we are still into the GPIO A, now we are going to use the ODR register. So what it means, I basically will come here. We can go ahead and replace the bit set register with the ODR register. Then we can remove the O operator because we basically just writing this value into the O register, right? It doesn't matter what else is in there because we know that upon reset, this register is actually 00. So we are now writing 31 by shifting it 4 times to the left. Right, then we delay. We come here. Now we can also go into that same ODR register. Now this time around, we can then write a 0 instead of what we were doing with a bit set register, where we were shifting also into specific bits and resetting them. Now we're just writing an entire register a value of 0 as it is on the reset. Now we come on this line of code, we can basically just have this code repeated here. Right, so this will be our statement for the sequence that is flashing at the reset when we press a reset button or when we release from any state. Then we go to case 1 where we are doing the count up, and in this case we can just remove this line of code. Then we come into this line of code, we're basically doing the count up. Let's remove the OR operator there. Then we replace the BSRR register with ODR. Then we will basically be achieving the same thing. So this will be it for this code. Then we move to case 2. On case 2, equally so, we're going to remove this line of code that was basically resetting. Then on the set, we can just do the ODR to access directly, and we can dish away the or leave it, but it doesn't matter because it's 0 upon reset. And we count down, and this is basically just resetting the counter, so we can leave it as is. Now we can go to case 3, which is a sequence case, and in this case we can also go ahead and remove this line of code because we do not need it. And in the bit set reset register, we can replace it with the ODR register, and equally so, we may or may not dish out the OR operator there. It's not going to matter at all. And that is it for this line of code here. Now we can test this right now before I actually promise to replace this line of code into a single bit. Let's reset here into a single line of code. Let's first just run it in just to ensure that our code is still operating. All right, okay, now we can go ahead and let's see where the reset is flashing. If I start counting down, I'm counting down, right? You can see it's working. If I release, it flashes. Now if I go to count up again, it's counting up. If I release, it flashes. So the code is still operating. So we are accessing directly the ODR register. Now let's now go ahead to finish up this tutorial to now replace this line of code. Now I'm going to make use of only the switch statement here, the SW. Right, that is storing the value for the switch. So which means I'm not going to make use of these two variables. So what I'm going to basically do is I'm going to take the switch. So I know that this button state variable is actually doing GPIO val, which GPIO val is this variable here. That's a register value, and I'm ending it, an end operation with this statement here. So which means if I take this, I copy it and replace it here, right, I will be achieving the same thing. So which means I can dish out this line of code already. Then if I take this statement, right, I copy this statement and replace it here, that basically means I can dish out all this line of code. So this statement is going to be exactly the same thing, because it is going to be achieving exactly the same thing. So I can go ahead and remove these two variables that I declared there. Now let's go ahead and write this in and see if it's going to indeed work. Okay, it's building. Well, build completed with no error, so which means the compiler is happy with what we just did there. The compiler is happy. We just saved ourselves space in the flash memory as well. Now the important thing is that it must still give us all the variable that we want, the status for our push buttons. Okay, well, what's going on here? Something is wrong. Something is wrong. You can see that it is just misbehaving. The code is misbehaving. Now we need to debug it. Now let's debug this line of code. The compiler is happy, but the operation is not good. So which means the buttons here, they actually just detecting crazy stuff. Look here, even though I'm pressing, but it's still crazy. So the switch statement is broken. So what's happening here is the GPIO B IDR, the statement is good, but this is one statement, right? This is one statement that we are actually shifting 8 times to the left. So which means we can actually go ahead and take this statement. Let's just put this statement into bracket like that. So we take this statement into bracket, and that basically we are making an AND operation of this statement together with this statement. So let's put this one also into the bracket. We close the bracket like that. So which means only the result of this operation must be shifted right 8 times. And let's see if that's going to now resolve our problem. Let's go. All right, debugger is launching. It's writing the code. Okay, well, as you can see, we are not flashing anymore, so it seems like it's happy. But is it working? Well, it seems like it's working. Let's count down. We are counting down. Okay, and it's flashing when we release. Let's count up. We are counting up. Okay, sequence. Well, the sequence is also working. Now you can see we basically just needed to put a bracket so that we can actually illustrate operation, because we know that this is the whole IDR register where we are inputting, and then we are ending it, making an end operation with this binary 3 that we're shifting 8 times to the location of our buttons, right? And the entire result is what we are basically just shifting right by 8. And that is now giving us the variable for the switch cases 0, 1, 2, 3. So that is it, guys, for this tutorial. If you've learned anything in this tutorial, please don't forget to subscribe to CMTEQ channel and give the tutorial a thumbs up. That will be highly appreciated. So you can see that we have actually cleared up and reduced our binary counter program. Now if you look at the first one that we did here, if I can just open that code, we're just going to compare, right? So this is the first code that we did for this binary counter. Now you can see it's quite a lot of code because we were using the hard drivers. So we went from that into just a skeleton program where we basically just accessing the registers. Okay, so that is it once again, and thanks for tuning in, and stay tuned for more tutorial like this. Until next time, cheers.